DevelopSec, Developing Security Awareness with James Jardine, brought to you by Jardine Software. Hey everyone, this is James with the DevelopSec podcast, episode 84, and today I want to talk a little bit about the importance of understanding the technologies that we use when we talk about application security. We talk about, as developers, understanding our frameworks, right? You're using .NET, you're using Ruby, whatever languages you're using, whatever frameworks you're using. This is important that we understand how our frameworks work and how we use those. But there's also kind of another layer to this that's kind of outside those frameworks, but it's just the technology in general when we talk about things like web applications or mobile applications, right? This is above and beyond where we think about the language that we're working in, and we get down more of maybe protocol-ish level of, hey, how does HTTP work? How does HTTPS work? Differences between them, why that's important. But then how do the different components that we deal with work at a much more in-depth level? So even thinking about HTML, how does that work? How does JavaScript work within the browsers? How do the browsers handle certain elements and how do those function? And this came up, I was actually doing a test for somebody, and we happened to notice something that was pretty interesting. So it was kind of a cool scenario where we had basically an open redirect or unvalidated redirect vulnerability where the application would take a untrusted URL. We talk about untrusted data all the time. Right? Untrusted data supplies the URL, and then after successful login, it would redirect the user to that arbitrary URL. We see this a lot when we talk about open redirects. Typically, we see it as a return URL. You just put it up in the query string. It's a beautiful feature to be able to allow us to, once we authenticate, go to the page that we were expecting we were going to go to. And this application happened to, I kind of just stumbled across this. It was really interesting because my session had timed out. It logged me out. But then when I logged back in, it took me back to the page that I was originally on. And I thought, wow, this is kind of neat. How is this working? And how can I look at this and say, is there some way to exploit this? And that's kind of the fun of when we think about security is, how can we look at things and figure out ways to exploit things, how an attacker may be able to do it, what they can do with that. Now, when we talk about open redirects, oftentimes, especially on a login screen, I love the example of being able to go make a carbon copy of the site that we're testing, go put it up there, and then I'm going to redirect you to that site after you successfully log on, and I'm going to prompt a message that says, oh, sorry, your logon has failed. Please try again. And if you're not paying attention, you don't realize that you're looking at a completely different site. You don't look at the address bar because you're looking at the page looks the same, right? There's no big significant changes in the page. Why do I need to recheck the address bar? I may have just mistyped my password. So we have this interesting scenario where I'm going to trick you into going basically to another login page to submit your credentials. Then I'm going to send you back to your page. Well, in this case, what I found was that the application was basically taking the referrer header and using that as the redirection value. So that's how, when it logged me out and it knew what page with what query string values to send me back to, it was the referrer header. Now, initially, when I thought about this, I was like, oh, great. Well, what am I going to do with a referrer header? That's easy to change on my own system, but how easy is that to change on somebody else's system? Because, it's one thing to be able to say, hey, I can perform this attack by manipulating this value. But then the next question is, well, how do I do that to somebody else? Because I don't want to attack myself. Right, just makes sense. Why would I want to attack myself? I could do that anyway. How do I get that to allow me to affect somebody else? And again, we go back to untrusted data, referrer header, any of these request headers, we don't want to trust them. All right, we always want to make sure we're validating them. But how am I going to get that to go? Well, you could think maybe, well, what if I create a page that has an applet on it? Like a Java applet or some sort of Flask object that allows me to manipulate more of the headers and provide that refer header, that might be able to do it. So I could send the user to the login page. I could set the refer header that it's going to refer back to my malicious page. That's a way we could do it. If those objects support that. But a lot of times what you think is, oh, wait, what if I just throw a link in a page? I mean, I can create a new web page, and on that web page, put a link tag to that other site, right? The site I'm trying to take advantage of. When you click that link, right, it'll make a call to that page, and it'll send that refer header as the page I just came from over to it. Now, here's where I think it's important that we really understand how we're working with things, like the way things work within the browsers, the frameworks, that type of stuff. Because if you just create a local HTML page to test this out, like, oh, you know what, let me just try this. Create a little HTML page, save it as .html on your file system, open it in the browser, it won't send a refer. All right, you won't see the refer header come across. At least when I was testing with Firefox, it did not do that. But if I go host that page on an actual web server, now maybe that's me running a web server on my local domain, not just loading up just an HTML file, or if you go run it out on another web server, when you click the link, it will send the refer header. So we're like, okay, well, we've gone a little bit further here. We've figured out, well, there's a way for me to trigger to get you to go there. Now, how's that going to help us? So now I've got to get you to come to my site, and then for some reason click on my link to send you back to your site to log in. All right, and we could probably work that out and come up with a scenario to get somebody to do that. So I click it, the refer header is my page, but when I log in on the other site, it's going to take me back to that same page that I clicked. So basically what I did when trying to put together a simple little exploit for this was when you come back to my page, it checks the refer header. Funny enough, right, that I'm checking the refer header there. I check the refer to see if it's from that domain, and if it's from that domain, then I actually display their login page that I've cloned instead of the page with the link to their login page. And when they log in, it submits it up to my page. I scrape the credentials, and then I send them back over to their site, and they're already logged in over there. But it was kind of an interesting thing. Now, what's important for us to remember about this type of scenario is that, we have to try to figure out the actual risk behind this. Okay, this isn't something where I'm just sending somebody a random link, and when they click it and go to their page and log in, it sends me over. Like, I've got to come up with a ruse, if you will, to get them to come to my site, click on the link, refer them over to their site, then it sends them back to my site, right? There's a few more steps involved, but it's doable. And as we consider that, we have to say, wow, that's not something I'm just going to write off because it's the refer header and not a query string value, right? It's maybe a little bit more difficult. I have to throw some more steps in there to get it to go. But the point is that we've figured out a way to twist this around and say, look, I can create a workable exploit where if somebody goes out to my site and they click that link to go log in, then we can, potentially trick them into handing over their credentials to that site when they walk through that process. And so it steps back to understanding how these things work. If I didn't have an understanding of how the refer header was being placed and how that worked and how I could pass that around, then it would be much more difficult to come up with an exploit scenario. And oftentimes we may have seen something like this and we said, oh, all right, it's the refer header. I'd have to do XYZ, jump through all these hoops. This is, likelihood is very small. But then when I come back and look at it, it's like, wait a minute, maybe the likelihood's not that small if we do it this way. And, it's that understanding of how the protocols work. It's that understanding of how HTML works, how the browsers work. All that put together helps us then kind of think out of that box of, hey, here's how I could produce this to create a way to exploit this that really isn't too far out of the norm, that I can expect us to actually be successful and not the worst case, if the stars align and, the planets all aligned, all that stuff. It's not one of those. It could be realistically done if somebody understood how those pieces laid out and walking through it with people, it's clear to see that it would be pretty believable as well. So that's just one example as I look through some of the things, as we're going through and we're testing and we're working with these apps from a security perspective, how do we look at them and we look at the vulnerabilities that are provided? How do I look at that and say, okay, how would I attack this? Because it's one thing to go through and do a test and say, hey, you've got this vulnerability. Hey, it's an open redirect. But somebody savvy enough would come back and say, well, it's the referrer header. How are you going to do that? Having that information and that idea of, hey, this is how we'd use that flaw to be able to exploit the system. Here's what we could do. This is the most likely scenario we use this for. Here's how it could be done. That adds a lot more to it, so we better understand it. So again, it's understanding how those pieces work. And I've got another example, which was something that I guess, I don't know, for some reason I just never realized. But, I talked about doing JavaScript in like an href tag, where we can put JavaScript in there. So you can do JavaScript : and an href, and it'll actually execute JavaScript you put in there. And I guess I've never given it much thought, because usually, we're doing things like alert boxes for screenshots, and we're saying, hey, look, we can do this. Or we're alerting out like the document.cookie to see, yeah, we can grab cookies. That type of thing. It's usually a single statement type of item. But, as I was hit with a roadblock during an assessment not long ago, I found that, I'm not limited to one, though. In that href, I can do JavaScript : I can write a whole bunch of JavaScript. I'm not limited to one statement. And, what's great about the industry is I'm able to learn something new. I mean, I learn something new all the time, and I like sharing that with other people. But that was one of those interesting things. I guess I just never given it a lot of thought. I knew I could do JavaScript there, but I never gave it thought that I could put a whole bunch of JavaScript. And so in this case, what we had was this pretty locked down system, to be fair, as far as from cross-site scripting. I could do the JavaScript : and I could do an alert, but things like single quotes and double quotes were all being properly encoded. So I couldn't do a whole lot there. I couldn't put script tags in. Those were getting blocked. So a lot of HTML elements were getting blocked. But JavaScript was readily available. And so it ended up being that I could, instead of just doing JavaScript : alert 9, I could actually just use JavaScript to embed my own script tags. And then, because I actually was trying to bring in a beef hook for an example, for a proof of concept, and so I needed to be able to embed a script source tag. I was able to just use, a couple lines of JavaScript to create a new element, add it into the head, set the source, and then to call the execute or the init on the beef script, and it was able to load it in and run it when somebody clicks my link. But very interesting technique to get past that, especially since single quotes and double quotes were encoded. But if with the JavaScript, the backtick also can be used to delimit literals. So when I'm trying to put in my string for where my URLs are, where my beef hooked script lives, right? I got to wrap those in some sort of delimiter. We could use the backtick, which is also not often encoded like the single quote and double quote are when we're talking about in attributes. So kind of an interesting turn of events as I was, messing around with that and trying to figure out how I could bypass this and take advantage of the very small window that we had. And we were able to get through that. So those are just kind of two examples of understanding much more than just the language you use, but understanding how do HTML elements work, how does JavaScript work and function, and how can we take advantage of some of that stuff. We've got so much stuff that's client side these days. Being able to really understand how those different pieces, like a link tag versus an image tag, how they function and what allows what, that we can, when we see something, better identify how we can take advantage of that. I can't tell you how many times you get into an assessment and you find out that, I can get a certain character to come back from a cross-site scripting perspective, but after that, I'm pretty blocked. They have me limited down, so I have to switch. For example, a lot of times I was testing one app, they don't allow script tags to come back. So you can put script in, but it'll manipulate it so it's no longer a script tag when it comes back down to the screen. But you can use A tags, link tags. You can use image tags. You can pass those up all day and they come back just fine. So you can then take advantage of things like the href JavaScript colon, or adding in your own attributes to an href like an on-click, those type of things. Or on the image source, you can do an image source of one that doesn't exist and then throw an on error and be able to execute your code that you're looking for. All of this while they're blocking out things like just a script tag. So from a development standpoint, making sure you understand how these technologies work, especially if you're taking things like HTML elements up in and you're going to send them back down, really difficult sometimes to be able to properly sanitize and remove out anything that could be vulnerable. So you got to be real careful there, but also having that strong understanding of, okay, I'm putting data into a link's href, or I'm putting data into an attribute. How could this be abused within this element, within the document? And how am I making sure that we're properly encoding against this so I can protect against it? Thinking about that type of stuff, because you have a better knowledge of how those items can be used or could be abused when you can throw scripting capabilities in there. Same thing when you think about the open redirect piece. Okay, I'm taking the referrer and I'm passing that down because, I'm probably thinking in my head, somebody can't manipulate the referrer, so this is a good way to do this. I'll just take it. Well, as we've always said, anything coming up from the browser can be manipulated, so we have to make sure that we're validating that. So can you take from the referrer? Sure, you can take from the referrer, but you should be making sure that you're validating that the domain that it's going to is the domain with your application. Maybe you're taking just the query string portion from the referrer and you're appending that to your own domain, right? Turning that back into your relative URL so it stays within your site and doesn't allow redirection outside of your site. That's what's going to help protect us, right? So it's understanding how those pieces work and that those are untrusted pieces of data. From a testing standpoint, right, this is an opportunity for us to be able to kind of think out of the box, get a little creative when we're identifying things. For me, when I think about QA testing for security, it's not looking for all those ways to be able to exploit it, right? Mostly I want to be able to point out, hey, you're not outputting coding a certain field, or you've got this data coming in and we're not validating it. I don't necessarily, from a QA perspective, need to show you how to exploit it, but if I can show you that I can manipulate that referrer and it will change where I do the redirection to, that's a flaw. Okay, and we need to make sure that we go through and we whitelist, or we make it relative, whatever we're doing to help protect that we can't do that. When we look at somebody doing penetration testing or security assessments, like a full security assessment, right, now maybe we're looking at, hey, how can I show how we could exploit that? How would we abuse this functionality? But from a QA perspective, I don't have to get as in depth of how I would abuse it. I just need to know, hey, when is this case actually going to be a flaw within our system, and how do I write that up to be able to send that back so we can get it addressed so it no longer becomes that flaw, right? We're not doing a whole lot of fully understanding that risk level there. We know it's a certain type of flaw. We know it's open redirect, right? We know this is possible that we could do this. Would somebody have to jump through hoops? Would it be super easy? Either way, we have open redirect. It's a coding flaw. We need to make sure that we go back and we address that and get that resolved so we can no longer manipulate this. So that way when it does come time for those assessments, when it comes time for that attacker who's looking at this, trying to figure it out, we're just going ahead and we're blocking that, okay? Because we validated that the issue's there. And when I cover that, the thing I want to include with that is when we talk about browser directives. When you look at all those response headers coming down from the browser, you got like the XS, XSS protection headers, you got content security policy, X-frames options, right? There's all these headers that are coming down to help us protect our apps. And I'm all for these headers, okay? Don't get it wrong that I'm, against these, that we shouldn't use them. I'm all for we should use these headers. It's a great thing. But don't just assume that because you have those headers there, they're protecting your app and you don't have to do things like your output encoding. Don't assume that I don't have to do output encoding because I've got content security policies set up. We should still be doing output encoding. And so we look at from a testing perspective, right? Hey, if I put in a less than symbol in an HTML context and a less than symbol comes back and not ampersand LT semicolon, that's something we've missed output encoding there. We should go ahead and we should be making sure that we address that there's a flaw there of how that's being returned. So just consider that type of stuff when you're thinking about going in, developing and testing your applications, understanding those frameworks, and more than the frameworks, but the protocols. Understand how all these pieces that help our applications run. I think we oftentimes overlook the things of HTML and really how they work because oftentimes they're just so simple, right? They're second nature. You put some tags on there, you make it happen, and it's very simple, and you overlook the fact that certain tags support certain features because you never use them. But from an attacker standpoint, if I know that that's there and you don't, there's a good chance you're not protecting against it. Now I get to go abuse that because you either weren't aware or you weren't thinking that somebody would think about doing that. So understand those pieces as you're going through building your apps. About 21 minutes this time. I hope you enjoyed listening to this. I hope the scenarios were kind of interesting. I know they're kind of fast. It's easier to obviously see them, but due to many reasons, we don't have any working POCs going with that right now. But there are interesting scenarios to think about as you go through this, right? The more scenarios we can share, the better testing people will have, the better understanding that people as developers will have of how could this be abused. That's the reason why I'm making sure that I'm protecting this, right? The reason behind why I'm doing it. We're not just saying, hey, do this. It's do this because this is what could happen. And, in this case, we're talking about leading to potential, credential theft. But of course, there's always all kinds of other reasons or issues that could arise from some of these vulnerabilities being out there. So as always, feel free, send me any questions, james@developsec.com, or hit me up at DevelopSec on Twitter. Reach out, share any thoughts. Always happy to have conversations about all this. So hope everybody's had a great year this year. Actually doing this one on Halloween right now. So we're getting ready this should be published today. So a nice little Halloween treat coming out to you. And if you got ideas, though, send them over. And hopefully we'll catch you on the next episode. You have been listening to the DevelopSec podcast with James Jardine. Follow us on Twitter at DevelopSec and visit our website at www.developsec.com for more episodes and information.